Okay, so as in the last video, we have already discussed about the types of the capacitors, and we discussed about the dielectric constants of insulating materials, right? So we discussed four basic types of the capacitors. We said that these are important, but not as much as we have covered our all previous topics, right? So these are important, but you know what, less important. These are in nota bola means very important, right? So these are not very important, but yeah, these are important but less important, right? So we discussed our four basic types of capacitors, right? We discussed about variable capacitors, then we discussed about the film capacitor, right? Then we discussed about the ceramic capacitors, and we had the second name of the ceramic capacitors as well, and which was disc capacitors, right? As you can see here, disc capacitors, right? Then we discussed our last type of capacitors as well, and that was electrolytic capacitor, which are highly or very commonly used in the DC power supply, as you can see this. And why are these used in DC power supply circuits? Since they are very large capacitance, they have very large capacitance value, and they have very small size to help them reduce the ripple voltage, right? This, the entire point is written. Why are they commonly used in the DC direct current power supply circuits, right? So we covered our four basic types of the capacitors: variable capacitors, film capacitors, ceramic capacitors or disc capacitors, and electrolytic capacitors, right? So let us write here ceramic capacitors or disc capacitors, right? Second name. So now, uh, then afterwards we discussed about, you know what, the dielectric constants of the insulating material, right? As you can see here on the page, we had a very less value dielectric constant of insulating material, and that was of vacuum, right? Then air, then telephone, then mineral oil, then polyethylene, then waxed paper, epoxy, PVC, nylon, bakelite, mica, and we have very large dielectric constant of insulating material of water, right? And here we discussed too that ER means relative permittivity or dielectric constant is never less than 1. It is always greater than 1 or equal to 1, right? Since you can see the values starts from 1 and goes onwards, right? And goes onwards means ER is always greater than or equal to 1, but it is never less than 1. It is always either greater than 1 or equal to 1, right? So in today's video we are going to solve our work examples. Not solve, however, it is solved in the book, right? We are gonna understand it, right? Because the direct steps are written in the book, so we should understand what they are trying to ask us basically in the question, right? So today, from today onwards, we'll be solving our work examples, then we will be moving towards our multiple choice questions and numericals of this book, right? So we are starting today this. I should write here the date as well, right? Today is 10 2023, right? So now see, read the variable, read the numerical first, right? Working example first, so that we can have an idea or we can have a data, right? We can analyze that what formula we'll be using here by reading the statement, right? So I'll be highlighting too whenever I'll feel that the data is given in the question, right? A parallel plate capacitors consist of two plates with an area 0.01 meter square, which means they have given us the area of 0.01 meter square, right? So area is given. each, separated by a distance of 0.002 meter. So they have given us the distance as well, which is 0.002 meter, right? The capacitor is filled with a dielectric material having a relative permittivity ER of 4. So we have dielectric constant as well of an insulating material, which is 4, right? So ER is equal to 4. Calculate the capacitance of the capacitor. Now what the capacitance of the capacitor would be equal to, they have basically asked, and they have given us the area of the plate, they have given us the distance between two plates, and they have given us the ER as well, right? We, as you remember, right, we have already discussed about the capacitance of a capacitor. If we are gonna have a dielectric medium between the two capacitors, right? Initially we derived our entire formula for the dependencies. We got to know that capacitance of the capacitor would be directly proportional to the area and inversely proportional to the distance between the capacitors or distance between the plates, right? So we got their formula of C is equal to epsilon naught into area, since it was directly proportional to the area and inversely proportional to the distance between the two plates, right? Then we placed a dielectric plate between the two plates. Then we got to know that the capacitance of the capacitor is increased by ER times, right? It was increased by ER times. Then we got our formula here, which is C is equal to epsilon naught, as it is increased by ER times, so ER into A upon distance D, right? So you can see here the formula epsilon naught ER A upon D. We derived this equation already in very detail, right? We put a charge density which was equal to charge per unit area. We derived an entire equation, and in the end we got our this equation C is equal to epsilon naught into area upon distance, from where we got to know that capacitance of a capacitor is directly proportional to the area of the plates and inversely proportional to the distance between the two plates. Then we placed a dielectric medium or dielectric plate between the two plates of the capacitor, and there the capacitance of a capacitor was increased by ER times, right? So afterwards we got our formula that C is equal to E means epsilon naught into ER times into area per unit distance, right? So we have got our formula now we just need to place our values in it and we need to solve, right? So the first step of solving a numerical is always to write a data. They have started with the formula, and it is not a good practice at all. Since I am teaching here physics, so you need to learn everything step by step, right? So we should not start solving a numerical with the formula directly, right? If there would not be data written, if you will not gonna know what is the data given in the question, how can you recognize what formula we can use here, right? So before writing the formula, we should write basically the data first, right? And afterwards they have written here the data. So the first step is always to write the data. Second step would be required value, right? So initially you need to write the data. In the data we have already got, they have given us ER, which we have written ER, right? They have given us area, which we have written here 0.01 meter square, right? And they have given us distance, which is 0.002 meter, right? We have already written that as well. And epsilon naught we already know that is the constant whose value is equal to 8.85 into 10 to the power minus 12, right? So we have written here this as well. Now this is the data. The second step of solving a numerical is always to write the required value. What is the required part in the question? So what they have asked us to calculate? Basically they have asked us to calculate the capacitance of a capacitor, which means the capacitance is required here, right? So the second step is to write the required value. The third step is to write the formula. What formula we're going to use here? Now we have written the required value, we have written the data as well. Now we can actually analyze what formula we'll be using here. So the third step is to write the formula, right? This is our third step. So we have got our data, we have got a required value. Now we can easily write the formula, and we have discussed about this formula as well. C is equal to epsilon naught times ER times area per unit distance, right? So now actually we have our values, we can actually put in this formula. Now fourth step is to solve, right? Or you can put the values which are given in your data in the formula, right? Third step was to write the formula. Now fourth step is to solve. So this is solution, right? Solution. So E epsilon naught, we already know the value, 8.85 into 10 to the power minus 12. We have written that, right? Into ER is already given in the question as 4, so we have written that as well. Into area is already given in the question, and that is equal to 0.01 meter square, so we have written that. Per unit distance, and distance between the two plates is given by 0.002 meter, and we have divided it by 0.002 meter, right? After solving this entire equation, you're gonna get capacitance of a capacitor that will be equal to 3.5416 into 10 to the power minus 11 farad, right? So the last step is always to write the result of your required value. So this is the fifth step, right? We solved our this numerical with 5 basic steps. Initially we wrote the data, secondly we wrote our required value, thirdly we wrote or we analyzed our formula initially, then we wrote it as the third step, fourth we did a solution of it. Initially we put the values which were given in our data in the formula, then we solved it, and lastly we got our result, that is the very last step of our solution, right? So we today solved the work example 9.1 with 5 basic steps of data, required value, formula, solution and result. So this was all for today. In the next video we're going to solve work example 9.2.